So, yesterday we looked at the notes for section 1-3 and we wrote down the equations. Now we need to go back and finish the problems. We need to solve the equations. And so that's why you need to have your notes out from yesterday, because we wrote these down in Kami, but now we're going to solve them in your notebook on notebook paper, because most of the time we do better with our solving on paper. So yesterday in problem number 1, it was a perimeter problem, and the perimeter formula is always 2L plus 2W. And that number is the perimeter that was given in our problem. And so you are writing this part on your paper and solving it out. Now, when we wrote this down yesterday, we said that you can solve it by substitution or elimination. How do you know which one to use? Well, obviously you want to use whatever's easiest, right? Since this is already solved for W, substitution is the easiest thing. And substitution was where you had the columns. You don't have to use the column, but the columns just help you keep everything organized. And so this is going to be the first and the last, and this one will go in the middle. And this one is already solved for W, so in place of this W, I'm going to put this part right here that's equal to W. And then I am going to solve it for L. So this is going to be 24 equals 2L plus 10L minus 60. Distribute and get your constant numbers together. 84 equals 12L. Divide by 12. And then L is going to equal to 7. Substitute in the 7 in place of L. And so the W will equal 5. Now, back over here on our notes, 4, write your answer in a complete sentence. So, oh, and I also actually did a little bit extra work because it said find the width. So, the width of the rectangle, it said in the problem that it was a rectangle, is 5 meters, because this one is the width, because we wrote down that W stands for the width. The way that I know that it's 5 meters is because in the original problem I was given meters. So that means the answer is also in meters. Problem number 2 was about Lisa's age and Jane's age, and I had these two, can't read my own writing, these two equations. Now, this one would probably also be pretty easy to work by substitution, but I'm going to work it by elimination just to show you an example of how you can work a problem by elimination. And if I am going to work a problem by elimination, we usually have it in standard form. We have to have the columns lined up. And so what do I have in this column right here? What variable comes first? This has an L first, so I have to subtract the 2L from both sides of this equation so that the L comes first, so that I can have my columns lined up. Now, when you are solving by elimination, it is your choice whether you're going to eliminate the L or the J. I'm going to choose to eliminate the L. The L has a positive 4 here, so I need a negative 4 there to eliminate the L. What number am I going to have to multiply by so that that will be a negative 4 right there? And if I multiply by 2 on this side, what do I have to do on the other side? And so then my two equations will be 4L plus 7J equals 169. 2 times 2, and that'll have a negative sign. 2 times 1, and 2 times 1. Add up the columns. What happens when you add a 4 and a negative 4? Those cancel out. 7, 8, 9. And so divide both sides by 9, and J equals 19. The problem says, how old is Jane? It doesn't ask me how old Lisa is, so I don't have to do the second part. It would be pretty easy to do, but the question said, how old is Jane? Do I know the answer to that? Jane is 19 years old. Question number 3 was, again, another age problem. So G stood for Mrs. Garcia, and D I don't think that's good English. 3 is the variable representing the daughter, and these are the two equations I had. Now, just want to mention that it's probably better form to use lowercase letters. I'm using uppercase letters because my own handwriting, the uppercase letters are a little bit easier to read just because my handwriting's not that great. So, this is already solved for G, so substitution will be the best choice. In place of this G, I'm going to put this part right here that is equal to G. I'm going to start it over here a little bit to give myself a little bit more room. And this needs to distribute. Combine like terms. When these have opposite signs, you subtract them and take the sign of the largest number. Those are both positive, so you add them up. Need to get the D's together. 3 subtract 2 is 1. We don't usually write the 1. Subtract 6 from both sides, and the daughter is 12 years old. This particular equation says find both ages. So I go back to this equation and substitute in the 12. That would be 3 times 12 is 36. 36 minus 1 is 35. Finish the problem by writing the answer in a complete sentence. Mrs. Garcia is 35 years old, and the daughter is 12 years old. Just supposing I came out with something like the daughter's 50 and the mother's 10. Would that make sense? So then that would mean I need to go back and look at my problem. Did I define my variables incorrectly? Did I make a sign mistake? And so you look at your answer and say, you know, the mother's age is more than the girl's age. Isn't that reasonable? And so use a little bit of common sense. The next problem was the problem about quarters and nickels. You can work that kind of problem with or without decimals. What is your choice? No, you can work it with decimals or whole numbers. If you look at what we wrote down yesterday, we wrote down the equation 2 different ways. One way with decimals and one way with whole numbers, and I don't hear anyone making a decision, so I will make a decision. These are the 2 equations. Since this is already solved for x, substitution is going to be the better choice. In place of the x, I'm going to put the 4y. Plus 0.05y equals 8.40. 20.25 times 4 would be 1. 4 quarters would be $1. Combine like terms. Divide by the 1.05. And this represents the nickels. In place of the y, put that number I just figured out. And according to what we wrote down yesterday, the x represents the quarters. Now, those of you that have the problems open, were we supposed to come out with more quarters than nickels? Yes, we were. And so, 1 has 8 nickels and 32 quarters for a total of $8.40. Our next example was about a candy mixture. We had two different amounts of candy worth two separate prices. To use elimination, we would have to multiply by decimals. That's not going to be my favorite. And so I'm going to solve by substitution. So I'm going to solve this equation. Let's write it down in our substitution format. Again, you don't have to use this format. It just keeps things organized. Now, you notice I didn't write that number down because I'm going to go ahead and multiply that out. This would be $35.10. I got that number from multiplying those two together. Now, over here in this first column, we have to solve for either X or Y. It really doesn't matter. There's not one that's more harder. What kind of English is that? There's not one that's more difficult. So what is your choice? You want to solve for X or Y? So somebody wants to solve for Y, so we're going to subtract X from both sides, and Y will be 30 minus X. So this Y right here will be 30 minus X. And so then you have to distribute then you have to combine like terms. And so that would be minus then you have to subtract the 40.5 from both sides to cancel that out. Divide both sides by negative 30. And you find X. In place of X, you are going to substitute 18. Subtract 18 from both sides. And get Y. So what does that mean in terms of the candy? We need to mix 18 pounds of $1.05 candy with 12 pounds, wasn't that what we got? 12 of $1.35 candy to get 30 pounds of $1.17 candy. You write the answer with a complete sentence. Problem number 6 was about a larger and a smaller number. Since this is already solved for x, in place of this x, I am going to put this part right here that's equal to x. I'm going to have 12 minus 5, and I'm going to distribute I'm going to combine like terms. I am going to add 23 to both sides. And divide by negative 10. I'm going to substitute the number I found. X was supposed to be the larger number. Is negative 1 larger than negative 4? Yes, because negative numbers are backwards. So the larger number is negative 1. The smaller number is negative 4. Okay, we're going to look at the assignment 113. We're going to look at problem number 1. Problem number 1 is about a camera. You do not get to define the variables. It defines the variables for you. What does it say x is equal to? What does it say that y is equal to? The cost in dollars of what? The dollars, the cost in dollars for the camera and the battery. Because you have to have a battery to run the camera. How many cameras do we have in this problem? So what is the equation for the first camera? How much does the first camera cost? And you have to have some batteries. How much does the battery cost? $5 or $9.5? Every year. So you have to multiply it by x, because you got to multiply it by 1 for the first year and 2 for the second year. X represents the years. What about the other camera? Plus times X because you got to buy a new battery every year. Good on the equations. These are both equal to Y. I'm going to solve it by substitution. In place of this Y, I'm going to substitute that part right there in place of Y. And I'm going to solve it for X. So I have to get my X's together. So this is going to be 47 plus 655, decimal point in there. So I'm going to subtract 47 to get my constant numbers together. And so 6.55x equals 12. And when I divide by 6.55, it doesn't come out to be a whole number. Rounded off. Now, what did we say X represented? Years for what? So let's go. Is everybody with me this far? Let's see if I can get the whole thing up here. This is the first camera. This is the second camera. This 1.83 years is how much it takes for them to be equal in cost. This is called the break-even point. At that point, they are exactly equal in cost. This can be a very important number. You sometimes get equations like this when you have businesses and you have a profit and a loss. If you have a business, do you want to have more profit or more loss? And so you have an equation figuring out how you get the profit. You have an equation figuring out what your expenses are that are causing you to have a loss. And you can figure out the break-even point. At that point, if you have more profit, that's good. If you have more loss, that's bad. And so that's what a lot of companies are dealing with right now, is they have more loss, more expenses than profit. Okay, back to this problem. What does part B ask you? Which is less expensive in the short term? Shorter than this. So you're going to go back to the original two equations. And you are going to substitute in X equals 1, because that's less than the break-even point. You're going to substitute it into both equations and see whether camera 1 or camera 2 would be a better choice. And then it asks you another thing. It asks you which would be the better long term. So we need a number bigger than that. And so let's not use 2. Let's use a number that's significantly bigger. Then you are going to substitute 10 into both of these equations and see which one is less expensive. Because when given a choice, wouldn't we rather spend less money than more money? Now, The rest of the problems are this one's not really like any of the examples, is it? That's why I wanted to do it with you. But the rest of the problems are like the examples that we did.